Good morning, children. Let us continue the same chapter, motion. In the last session, we were discussing about the graphical representation of motion, and that two types of graphs were discussed. One is distance time graph, second, velocity time graph. In those graphs, we calculated something. In distance time graph, slope. In velocity time graph, also slope and area. These two things were discussed. Then the most important topic, that is equations of motion. To describe the motion of any object, we have set of equations. There are basically four equations of motion, but at this level you have only three equations of motion. Generally, these equations are used in the uniform accelerated motion, but it can also be used in uniform motion by taking special case. First, we'll list out the equations of motion. First, V equal to U plus AT. The symbols, as usual, they have the meaning: final velocity, initial velocity, acceleration, time. Then S is equal to ut plus half a t square. S, capital letter S, represents the total distance, but actually it is the displacement. Since we are talking about the object is traveling in the same direction, in that case both distance and displacement are equal, so we can say this is distance traveled. S is equal to ut plus half at square. Third one is v square is equal to u square plus 2as. These are the three equations of motion. In all the three equations of motion, we have the acceleration, and that is uniform acceleration. And one more quantity is also common, that is initial velocity, present in all the equations. Except these two, initial velocity and acceleration, if we see, this first equation has velocity and time. Second equation, it has distance and time. Or you can say it is displacement, or you can say it is the position. Third one is, this is final velocity and distance. So, on the basis of these, the first equation of motion is also known as velocity time relation. Second, position time or distance time or displacement time relation. Third is velocity and position relation. These are the three equations of motion. Now, these equations can be used to measure any of the quantity: final velocity, initial velocity, acceleration, time, distance. These things can be calculated, and also the time taken. These things can be calculated if other variables are given. Before going for that, we must know that how these equations are obtained. That means we say that is derivation of these equations. These three equations are derived by taking some concepts. And there are different methods for the derivation of these equations. But in your class, you have only the graphical method of derivation. Means we obtain these relations, these equations of motion by the graphical method only. We'll see the derivation of these equations one by one. First, we'll see the derivation of the first equation of motion. For that, consider an object is traveling. An object is traveling with its initial velocity u. This is velocity graph, velocity axis. And this is time axis. In this, the object is having the initial velocity and its velocity is increasing equally in equal interval of time. That means the object is in uniform accelerator motion. If it is in uniform accelerator motion, then we will obtain this type of graph. After some time t, after traveling for some time t, its velocity become v. Its velocity become v. Here the velocity become v. Let us take, this is the point A, B. Now this is the velocity time graph in which we get the straight line. Here we are going to find the slope of this graph AB. We know already the slope of VT graph gives what? It is the acceleration. Here if you find the slope of AB, slope of AB. To find the slope, we have to draw the parallel axis to the time axis. Let us take, this is C. Now the slope of AB, that is equal to perpendicular to base. Here we take the angle. And this is BC over AC. BC, point B represent V, point C represent U. So this comes V minus U upon AC, that is equal to this value. Let us take, this is the point D. Here this much of length, that is in the time axis, that is equal to T. But the slope of this velocity time graph gives the acceleration. So therefore A equal to V minus U upon T, and we get V minus U is also equal to AT. Then V equal to U plus AT. So this is the first equation of motion. In this method we get the first equation of motion, V equal to U plus AT. I said this equation is used for the uniform accelerated motion. If it is having the acceleration, we use this equation. If the acceleration is 0, if acceleration is 0, then this term comes 0, then the equation become V equal to U only. Final velocity is equal to initial velocity. If there is no acceleration. If there is acceleration, V equal to U plus AT. So this is also known as velocity time relation. This is the first equation of motion. You need to, means you must know how to derive this formula also. This is one equation of motion. Now we go to the second equation of motion. For the second equation of motion, again the same graph. We use the same graph. For all the three equations of motion, the graph is same. The graph is same, but the method is different. Method of derivation is different. And in that case, we will not find the slope of this VT graph. We will find the area of the graph. We will see that derivation in the next video.